Hi everyone, welcome to the new session. In today's session, we are going to talk about inequality, and our main focus is going to be on x and 1 over x, how 1 over x is going to behave from the given value of x. Okay, so we are going to deal case by case. Okay, so my first case I will start with is when when my when the signs on both sides of inequality are same. Okay, so here I will say that my both a and b, they are positive numbers. Okay, so here a and b have same signs. Okay, so if they have same signs, then what will happen? If they have same signs, then from here I can write a, it is greater than b. Okay, so I just took this thing from here. Okay, so if I do the reciprocals, 1 over a, 1 over b, if the signs are same on both the sides, then when you take the reciprocals, then the sign of inequality will get inverted. It has to change. Okay, so here it's going to be less than. Okay, so this is important thing. Okay, so when signs are same, then here you can write uh, while while taking reciprocals sign of inequality alters. Okay, so we'll try to understand it from the example. So here let's say that 7 5. Okay, which one is greater? 7. If you do the reciprocal, if you take the reciprocal, then because this was greater, this is greater compared to this, right? So overall value will be smaller. So see, so the sign has changed. Okay, I hope you understand it. Here you can take one more case. 10, it is less than 100. Okay, if you do the reciprocal, now see here, lower value, this one is going to be higher. Okay, so the sign alters. Okay, so whenever the signs are same, then on taking the reciprocals, the sign of inequality has to change. Okay, and here second case, I won't say second case, it's a part of first case. So here, if your a and b both are negative real numbers, right? So then again, they have same signs, but this time they have negative sign, right? Because they are negative real numbers. So from here, I can say A is less than B. Again, negative, negative. So when I will take their reciprocal, the sign has to change. So this has to be greater than. Okay, important result. Okay, so let's try to understand it from the example. Here I have minus 5, here minus 1. Which one is greater? Obviously, minus 1 is greater. This is smaller, so here this. But if you do the reciprocal, okay, minus 1 over 1. Now, because this is smaller, okay, so this is smaller. So the overall value, it's going to be higher, okay? So the sign has to change. I hope you understand the point. Okay, so that's what it means here. Now go to the next case. Let's go to the next case. The next case says that what if the signs are opposite, right? So here you could say uh, something like this, right? Where your a and b, they have opposite signs, right? So here you can see from here that b is positive, a is negative. A is negative, so a is less than b. They have opposite signs. Okay, so when you have opposite signs on both sides of inequality, then what would happen? Then you are on taking the reciprocals, the sign will remain the same. Here less than, so here less than 2. Okay, important result. Okay, basics but important. So here let's try to understand it from the example. So here I have minus 10 and here I have 10. Now obviously you will say this is smaller, right? When you do the reciprocal, minus 1 by 10, this is 10 by 10. Now, obviously, because this is positive number, so it has to be higher than the negative number, sign will remain the same. See here, the sign remains the same. Okay, so I hope it made sense to you. Okay, now let's see how if uh, now what I will do is I will take some cases where I'm going to represent x in the interval form, and then we will study the behavior uh, of 1 by x. Okay, so first case, when my interval is positive, so let's say that my x belongs to 5 to 15. Okay, 5 to 15. So now see here, if my x belongs, okay, so this here I'm going to do all the explanation part. Okay, if my x belongs to 5 to 15 open interval, it means, what does it mean? It means uh, x lies between 5 to 15. I hope you agree, right? Now 5 to 15, it's a positive interval, right? It's it's a positive interval. What does it mean? All the possible values that x could take, they are going to be positive. So when I'm dealing with inequality, so it means that I have positive numbers on both the sides of inequality. So when I have same signs, then what would happen? Then my inequality sign, it has to change, right? So here, when I will take the reciprocal, 1 over 5, right? So what would happen? Here, it's going to be this. Okay, so your 1 over x, it's going to lie between now see here, this is higher number, so your 1 over x, it's going to be, this is higher, right? The denominator is higher compared to this, so it means that the overall value will be smaller. So when you represent it here, it will be minus, sorry, 1 by 15 to 1 by 5 open interval, 1 over 15 to 1 over 5. All right, I hope you understand it. Okay, now let's take a second case when my both numbers are are negative. Okay, now see here, this time here x belongs to minus 15 to 5. Now see here, all the possible values that x could take are going to be negative, right? So another way to write this would be minus 15 to minus 5, sorry, minus 5, right? Why? Because minus 15, it is smaller, right? Because if you see the number line, minus 5 here, minus 15 here, so as you go towards left, the number keeps on decreasing. That's why this is smaller, this is higher. Now again, because x could take negative values, it means that same signs on both sides. So the when you take reciprocal, the sign has to change. So if I do 1 by x, so minus 1 by 15 here, so the sign will change, right? Okay, so here sign will change. So what I can say from here, now see here, this was higher, right? This was higher, and this was lower. Okay, and here, if I have to represent 1 by x, then I would say which one is going to be lower, minus 1 by 5. Why? Because here it was greater, right? It was higher. So when you did the reciprocal, so the higher value came in the denominator. So overall value is going to be lower. So this 1 over x, it belongs to the open interval minus 1 over 5 to minus 1 over 15. I hope you understand it. Right? Now, let's take the third case when let's take the third case when your x belongs to minus 5 to 15. Okay, now this is a little interesting. Uh, just give me a second. All right, so when my x is when my x lies, not my x, when value of x is between minus 5 to 15, right? Now, the problem is that now if I break this interval, I can get two intervals, right? See here on number line, this is minus 5, this is 0, and this is 15. Okay, now this interval represents this thing on the number line. So I cannot take this. So here I put hollow dots, right? So I can break this thing in two intervals. How? I can say here that in this region, I'm talking about this region. Okay, in this region, my x, it's going to be negative. Why? Because it will lie between minus 5 to 0, right? And in this region my x will lie between 0 to 15. Okay, so now here you can ask me why did not I include 0? Okay, I cannot take 0 here because 1 over x is not defined for x equal to 0, because if you do 1 by x and x is 0, then it's going to be not defined, right? So here I cannot include 0. Okay, so now what would happen in this region? In this region, x will take the negative values, right? Negative values. And in this region, x will take the positive values. Now see here, both the values in this region is going to be negative. Both the values are going to be positive. Same signs. In both the cases, you will see the same signs on both sides of inequality. So when you will take the reciprocals, the sign has to change. Understand? So I can write here what I can write here. So if I do the reciprocal, 1 over x for this side, okay, so this thing, it's going to be infinity. So here uh, minus 1 over 5, right? So here this thing will come, right? And here, if you do the reciprocal, here 1 over x, here 1 over 15, here this is minus infinity, and here you will get again infinity here. So the sign has to change, right? So it's going to be this. Okay, so overall, if you see this thing on the number line, this is 0, this is minus 1 by 5, and this is 1 by 15. So what it says, your 1 over x, it's going to be in this region. Okay, in this region. And here, your 1 over x, it's going to be greater than 1 over 15. So it's going to be in this region. Okay, so from here, I can say that my 1 over x, I can represent it as minus infinity to minus 1 over 5 union 1 over 15 to infinity. Okay, I hope you agree with it. All right, now let's move to the, so we have taken all the cases where your uh, where x is positive I mean when the signs are same, positive. Then second case, when again the signs are same, negative. And then when you have positive and you have negative sign, right? Opposite signs. Okay, now uh, there is one more case which is very, very important. So we'll see what it says. So the case says that it's going to be number 3. Okay, it says that uh, if your x belongs to a b, okay, if your x belongs to a b, then what would happen? Then if your x belongs to closed interval a b, then 1 over x, it will belong to 1 over b to close interval 1 over b to 1 over a. Okay, condition a and b have same signs. Understand? If it is open interval, so again x belongs to open interval ab, then again 1 over x belongs to, it will stay the same except one thing, the interval we are going to use, it will become open. Okay, here it was closed, here it is open, because here for x we have open interval, so 1 over x will also have the open interval. Now number 4, important, we are going to work on it. Okay, so number 4 says that if you're, we have worked on that, the cases that I took. So it's just the conclusion. So here, if x belongs to your open interval a to b, and when a and b have different signs, then your 1 over x, it's going to be minus infinity to 1 by a union 1 by b to infinity, right? Now see here, a and b have different signs. A and b have different signs. All right. Similar case. See here, a and b have different signs. Then your 1 over x, it's going to be minus infinity to 1 by a. So 1 by a here, minus 1 over 5. Okay. And if again, the same thing. If the interval is open, then 1 over x will belong to minus infinity to 1 over a open interval union open interval 1 over b to infinity. Okay, so these are important results. So the questions that we did before, this is just the conclusion. Okay, so I hope